Well, hello and welcome back to math class. You're going to notice on the screen I've gone back to lesson 9. We're looking at lesson 9, module 6.1. One of the reasons why I did that is because I think we want to do a little bit more practice with ratio tables and being able to solve them. So if you guys could open up your books to S35. S35. All right, so as you look, we have 3 ratio tables that I want to see if you can go ahead and fill in and see if you can find the missing numbers. Find the missing numbers. Well, if we look here, I can see on this one, I have 2 numbers next to each other. And in order to go from 12 to 16, it looks like I'm adding 4. 12 plus 4 is 16. So it looks like my pattern is going to be on this side, adding 4. So I would probably do, what is 16 plus 4? 20. And 20 plus 4, oh, it works great. Going the opposite direction, I'm going to have to subtract. So 12 minus 4 would be 8, and 8 minus 4 would be 4. So now I have a pattern, adding by 4. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20, and 20 plus 4 is 24. I'm going to highlight this as a pattern. We're adding by 4s. Okay, let's look at the other side. Doesn't look like I can go across. And remember, when we go across, we have to multiply. I can't take 8 times anything to get 22. So it looks like we have to find the pattern here. What's nice is I've got some numbers next to each other. 44, 55, 66. It looks like I'm adding 11 each time. Well, some of us are noticing that this must be 33 and 11. So we added 11 each time. So I'm going to highlight this pattern. And what did we do? I'm going to highlight that we added 11 each time. Over here we added 4. All right, let's look at number 2. Oh, I see a pattern here. It looks like here I added 5, so write that down in our book. So we're probably going to add by 5s. So this would be 20, 10, and 5. Let's see if that's correct. 5, 10, 15, 20, 25, 30. Very good. So the pattern was adding. And what did we add by each time? We added 5 each time. On this side, I notice I can't multiply across. 10 doesn't go into, so it looks like I have to look here at 14 and 21. Now, if I don't know what the difference is, for those of you that couldn't figure that out on your Google form yesterday, you need to take the larger number, which is 21, and you need to subtract 14. And if you do that, you will get the answer 7. So it looks like we took 14 plus 7. So we're going to add 7 each time. I'm going to subtract this. So let's see. 7, 14, 21, 28, 35, and 42. So of course it looks like we are counting by 7s. What are we counting by? 7s. Okay, let's look at problem number 3. Go ahead and see if you can solve these for me. Okay, you will notice that I found out that each time we were adding the number 3. This was our pattern all the way down. 3, 6, 9, 12, 15, and 18. So we were adding by 3s. Okay, let's see. What did you figure out on the other side? Oh, this one's not quite as obvious. I have 2 numbers here and 2 numbers here. I have to figure out what they're adding by. Well, once again, I'm going to do what I did over here. We have to take the larger number, which is 51. We have to subtract the number that's right before it. and I get 17. Let's check this one here too to make sure. The larger number minus the number right in front of it, I get 17. So it looks like every single time I'm adding 17. So I have to add 17 to 51. Well, that would be 68. I have to take 34, and this time I have to subtract 17. That would be 17. So it looks like I have a pattern of counting by 17s. And once again, on this side we added by 3s, and on this side we added by 17s. All right, before we move on to some new ratio tables, I want you to write the ratio, the value of the ratio for the table. So for example, table number 1, we want to find the smallest ratio, and that's this one right here. Can 4/11ths simplify? 4 and 11 do not have a common factor, so our ratio for this one would be 4 to 11. Let's look at 5 and 7. It's the smallest one. 5 is prime and 7 is prime, so this one will not simplify as well. And we look up here, here's our smallest ratio. 3 is prime and 17, so that means there aren't any factors to go into both. All right, so I want you to actually scroll down here. You have plenty of room down here, and we're going to make some ratio tables. We're going to practice some things. So what I would like for you to do is I want you to go ahead and make here a box. And of course we're going to cut it in half like this. And then I want you to make here 4 rows. I'm going to give you some numbers. And I want to see if you can solve the missing integers. Pause your screen and go ahead and see if you can figure it out. So it looks like on the left side, I'm adding 2. 3 plus 2 is 5. 5 plus 2 is 7. So I'm going to add 2 once again. That's 9. I don't know what I'm counting by over here because I don't have 2 numbers next to each other like I did up here. Let's see if we can go across then. Can I go from 3 to 12? And remember, once we're going this direction, we have to multiply. 3 times 4 is 12. Let's double check if this one does the same thing. What is 7 times 4? It's 28. So that means we're going to multiply by 4. So this would be 20. And this one would be 36. So we're going to notice on this side we counted by 2s. Then we had another pattern, and I'm going to use a different color because we actually multiplied by 4. So I'm going to put that right down in the middle. We were able to multiply by 4s going across. Some of you now can see the pattern over here. We added 8s on this side, plus 8. So we had another pattern on this side. Okay, let's try another one. So get ready to draw another box. All right, write the missing numbers that I have, and I want you to fill in the other spots for me. Go ahead and pause your video and see if you can solve the patterns. Well, it looks like I've got 2 numbers here next to each other, and it looks like I went from 3 to 6. I added 3. So if I add 3 again, that's 9, and oh, it works here. So we counted by 3s on this side. Now, the only way I can figure out what we're adding by on this side would be to take, remember the biggest number and subtract the one that's right above it. So we'd have to take 240 minus 120. And I found out it's 120. So it looks like from here to here, I added 120, which means I have to add 120 to 240. Well, if I add 240 and 120, I'm going to get the answer 360. I have to add 120 one more time, and that would be 480. So this had a pattern of counting by 120s. But I think I could have also gone across. Let's see. Can 3 go into 120? Looks like 3 goes into 12. I know 4 times with a 0. Would that have worked here? Could I have multiplied by 40 right here? 6 times 4, 24 with the, yes. How about 9 times 40? 9 times 4 is 36 with the 0. 12 times 4? 12 times 4 is 48. And because I have 40, I have this. Oh, looks like we could have also solved this one by multiplying across as well. The ones up here did not work that way. We could not take the numbers in the first column and multiply them into the second. Okay. Of course, we're going to do another one. Be careful on this one. All right, I want to see if you can find my missing numbers. Okay, so let's look at this last ratio table we have. If I look, to go from 2 to 5, I added 3. To go from 5 to 6, I added 1. And 6 to 10, I added 4. So there's no pattern over here. And because there's no pattern over here, I can't highlight it. And that means if I can't do a pattern on this side, I can't do a pattern on this side because it's not going to be the same. So the only way I'm going to be able to solve this is I'm going to have to go across this direction, which means I'm going to have 2 times something is 16, and most of us know 2 times 8. So 5 times 8, that worked here. So that means I'm multiplying by 8 in all of these. 6 times 8 is 48, and 10 times 8 is 80. Now if you notice, we did not add by the same thing all the way down, so there's no pattern counting on either side. The only way we could solve this table is by multiplying through the middle. Okay, well, the next lesson we're going to actually start looking at some ratio tables and making some comparisons. However, before we do that, let's go ahead and let's write our ratio for this one. Looks like the smallest one here is 3 to 12. Oh, 3 to 12. That can actually be reduced. The number 3 goes into both of them, so we're going to say our ratio is 1 to 4. Our ratio for this one, the smallest one looks like it's right up here, 3 to 120, and once again, that can be simplified by the number 3. 3 goes into 3 once, and 3 goes into 120 40 times. The last one we're going to look at, my smallest ratio is 2 to 16. They both are even, which means I can divide them by the number 2. So we have 1 to 8. All right. Well, thanks for paying attention. I hope you understand ratio tables a little bit more.